Okay. My clock reads 3 p.m. Central Time. Might be a little different from wherever you're joining us, but good afternoon and welcome to the Tree Fund webinar series. My name is Bo Broadbeck, Extension Specialist here at Auburn University and Chairman of the Board of Trustees with Tree Fund. Today I will serve as your host and co-moderator for the webinar. I would first like to welcome you on behalf of the Alabama Cooperative Extension System. We're the outreach arm of Alabama A&M and Auburn Universities. As always, we are honored to participate and host the Tree Fund webinar series. Before I turn the webinar over to my co-moderator, I would like to cover a few housekeeping items. During today's webinar, please submit your questions to the Q&A box, and I will bring those to the speaker's attention. If you have questions for us, please monitor the chat box. You can put questions into the chat box. We will be putting some extra information in there, so keep an eye on the chat box for us. We are recording today's webinar, and so this webinar will be available on the Tree Fund webpage in usually about 1 to 2 days. So check in there and you'll be able to rewatch it or share it with somebody who did not get a chance to tune in. For those of you needing CEUs, for the last few weeks, our CEU policy has changed. For ISA CEUs, we will now be submitting those CEUs on your behalf. It'll be based on the information you provided during registration, as well as today's attendance record. So please be sure to stay on for the entirety of the call so that we can award you those CEUs. Those needing SAF Forester CEUs, it'll work the same way. We will award those based on today's attendance records. Jim Urban is going to talk a little bit about the LACES CEUs and the requirements for those, and so I'll just leave that to him. So to welcome you on behalf of Tree Fund, today we have Jim Urban joining us, and he will actually be co-presenting with Andrew Koeser today. So he's going to give us an update on what's going on around Tree Fund, and then we'll transition into the presentation. Jim, I will turn the floor over to you. Thank you for being here.
Okay, well, thank you, Bo, and good afternoon to everybody. So I'm Jim Urban, landscape architect. I'm also a Tree Fund trustee, which is, I'm now retired, which is good. I changed my picture out from a business picture to a retirement picture, and Tree Fund has become my retirement project. Let's see, why is that? There we go. So the Tree Fund is about the support of scientific discovery and dissemination in the fields of arboriculture, urban forestry, and I've taken the liberty of adding landscape architecture through grants, scholarships, and support for arboricultural education. We are trying to broaden out our original base of arborists and urban foresters, and much of what I've done over the years in terms of bringing information to landscape architects at ASLA meetings has come from information generated by Tree Fund. We have an extensive research archives of past grants that have been published, which you can go on to our website to find. We have 3 webinars scheduled coming up, one on mycorrhiza, a continuation of Brian Scherenbach's soil assessment for urban trees, and then a session on measuring multi-stem trees that's going to be in October. So if any of those interest you, we're glad to have you on board. Unfortunately, due to this coronavirus pandemic, our donations have really cut down, as they have in most nonprofits. These webinars are put on for free, and we will continue to do that. But we really need a special donation from each of you to help keep Tree Fund financially healthy. So either during or after the presentation, just go to treefund.org and hit the donate button. And if we got a $20 donation from each person on this webinar, we'd raise over $20,000, which would really help us for our daily funding needs to keep the tree fund healthy and moving. Just a word about CEUs for landscape architects. We are offering LACIS CEUs. Unfortunately, we will not be offering them for the archive version of this, so you have to be on the program today. At the end of this presentation, there'll be a link in the chat box that you have to click on. You'll see the standard LACIS 10 question test that you have to take, and you have 10 days to complete that test. And our support for LACIS CEUs are supported by Deeproot, who's handling the work to develop the certificates. So we were originally going to have Andrew Benson from the UK working on this, being the presenter. Unfortunately, he had to drop out at the last minute for some scheduling conflicts. Andrew Koeser from the University of Florida, who was a co-researcher with Andrew Benson on the work that's was to be presented, is going to present the work of the research, and I'm going to present the part about the applications of the research to for landscape architects and designers, arborists who are actually in the field trying to interpret this data. I'm going to present first, and then Andrew will come on after I'm completed. Okay, so I have to flip over to here. So this is going to be about preserving trees in difficult urban sites. And the work that Andrew, the two Andrews worked on was work that helped us refine the establishment of a tree protection zone. ISA developed a number of years ago a best management practice called Managing Trees During Construction. The research was very good at confirming that a number of the assumptions in this best management practice manual were reasonable. So we have some better science to support this particular manual. The manual sets the size of the tree protection zone from somewhere between 6 times DBH to 18 times DBH, which is a really wide range. And I'm going to hopefully help you to figure out how you refine that. So two important things in defining the tree protection zone, which basically starts with the trunk of the tree, but also has to look at the species tolerance to construction, the tree's age, and in the manual there are different distances from the trunk per inch of diameter, depending on the species tolerance and the tree age. And there's also a chart in this manual that shows tree species tolerance to construction. It doesn't cover every tree you'll ever find, but it will cover a vast majority of the trees that landscape architects might be working with in their region. So the effective size of the tree protection zone can depend on, in addition to the trunk diameter, the tree health, so its vigor and structure, the tree age, as I said, and species tolerance to construction. the anticipated existing or anticipated changes to soil or grading. It's important to know that soil compaction and soil hydrology can significantly impact the extent of the tree's root zone. And then there are also planned incursions into the tree protection zones, such as grading, paving, structures, and utilities. And while I am a landscape architect by training, I strongly recommend that as landscape architects, we should be working with consulting arborists to determine tree health and vigor. It's not really something we are trained to do. And it's an important factor in determining the suitability of any tree to withstand proposed construction. Actually, when I have a very large old tree to work with, even in my practice, I don't do that myself. People think that I'm a good tree guy. I hire an arborist. So I would expect that you all would also. So we have the tree protection zone, which, as I say, the BMP is 6 to 18 times the DBH, and that's the diameter, that's the radius of the tree protection zone. Make that very clear. So it's the radius of that red dashed line is 6 to 18 times the diameter of the trunk at 4.5 feet above the ground. There's also in the manual discussion about a critical root zone, which is far inside of the tree protection zone. And this is an area which is really sensitive to root cutting, grade changes, other things that we may do. And we have to think about that area as separate from the tree protection zone when we're imagining how we're going to treat both of these. And the critical root zone size is not defined in the BMP, but 3 times, the radius being 3 times the diameter at breast height is a good starting point for that particular critical root zone. So the problem that we have is that the BMP defines the tree protection zone, and there are requirements for what you need to do in there. And you shouldn't be compromising these requirements based on other project requirements. And that should be the basis for the work that we do. However, on most urban projects, you just can't say stay out of the tree protection zone. Just not gonna work. So then what do you do? Okay, so how much can I compromise the tree protection zone with various kinds of incursions into there? And I have found that you can usually impact about 1/4 to 1/3 of the tree protection area with minor mitigation, such as additional watering, root pruning, and mulch. And by the time you get to half of the impacted area, it becomes very difficult, and you may have to do extraordinary mitigation. And it assumes that there is no deep cuts within the remaining tree protection zone, and we've stayed out of the critical root zone. But disturbing more than half that area is never recommended. And so you really want to fight for 1/4 to 1/3 for incursions into the tree protection zone. The other thing is that the tree protection zone is almost never a circle in an urban area. This was a project that I did many years ago. The yellow dashed lines represent what the calculated tree protection zone was. And the red dashed line is what we established as the tree protection zone. And you can see that we've cut close to 1/3 in some cases. And at the top of the screen, there are 3 trees that have yellow trunks on them, which were in very, very bad health. And we were cutting more than half of the tree protection zone for those trees. We recommended that those trees be removed. The client felt that we had to save the trees because we promised the city that we would save the trees. And I said, well, we're not going to be able to do it, but you know, and all three of those trees died shortly after the end of the construction. So it's difficult to do that. Also, in this particular project, there were incursions of paving and grading, which is the tan area that I've shown in this diagram. And we did some minor grading, in some cases, some fairly significant grading, and lots of paving within the tree protection zone. And with the exception of the 3 trees I mentioned, all the rest of the trees survived quite well. 15 years later, they're still looking fabulous. So when we're going to put an incursion into the tree protection zone, first of all, we need to keep it out of this critical root zone. That's the first and most important. And secondly, if we have to do paving, design the grades and the paving so that the paving sits on top of the root zone, not cutting into it. If we have to cut into the grade, we need to do that with an air spade so we know what kind of roots we're damaging, and we can do certain things to protect roots or decide which ones we're going to cut. And if we're going to fill on top of the grade, there are things that we can do to dramatically improve the chances of the roots surviving this particular efforts. There are a number of resources that we can go to in addition to the manual. My book, Up by Roots, has a whole chapter on tree building around trees. There's a fabulous book, Trees in Development, by Nelda Matheny and Jim Clark, which is a complete set of how to work around trees. And coming, they're just getting started, a new app called, or I guess it's not, it's really a program called Tree Matrix at treematrix.com, where they're designing a program to define tree protection zone and predict tree survival with this particular program. There's also a good specification on writing specs for tree preservation prepared by the Urban Tree Foundation at urbantree.org. It's a free download in Microsoft Word, so it's amendable. And there are also a number of CAD details that you can download and put them on your drawings. So the tree protection zone and its defining is only part of the process. You're never going to really save the tree by just drawing the tree protection zone and walking away. There are a number of critical steps that you've got to check these boxes, and the more of them you check, the more likely you will be successful. And the first, most critical, is politics. How badly does the stakeholder want to save the tree? It's practically impossible to save a tree if the client is just giving lip service to do it and doesn't give you the support financially or otherwise to save the trees. Each tree has its own set of politics. My favorite set are the Davy poplar at University of North Carolina, Chapel Hill. This particular tree was the tree that Mr. Davy tied his horse up to when he picked this spot for the university. And you don't get near that tree and they'll spend any amount of money they need to keep it alive. On the other side of the building, the quad is also, the trees are important, but they really struggle against the competing politics of tailgate parties and other events they hold in this. And so it's a constant battle. And then at the other end, you've got just large tree on private residence in a neighborhood where there isn't enough money to really do what you need to do there. And the politics might not work very well to make that happen. The second is the budget. saving trees in urban areas is expensive. You're going to have to do all kinds of special construction techniques to eliminate or to reduce the amount of damage to the root zone. It's not unusual to spend on my projects $30,000 or $40,000 per tree in tree protection efforts to make to really save a large tree. The third is, what is the skills and motivation of the design team? You have to have the whole design team on board. If you're just the only voice, the Lorax crying out for saving this tree, you're not likely to be successful unless the rest of your design team is on board with you. And the things that you're asking for often have to get reflected in the work of all the other designers, particularly the civil engineers, lighting, irrigation, planting. All of those things can affect the success of tree preservation. The next step is the evaluation of the tree, and is this tree a good candidate for construction preservation? And the health and structure of the tree is critical. So this middle illustration, the tree looks like it's a pretty good candidate, but when you begin to investigate the base of the tree, you find that there's a fairly significant rot at the base of the tree. And you're going to have to either decide whether you can work around that or not. I've seen some trees that landscape architects, including myself, have said, we got to save this tree. And we just finally came to the conclusion that it wasn't a good enough candidate. The third are the site conditions. What are mitigating conditions that may make the problem easier or harder? This is the tree that I showed you in the early slide that we saved. And so while the tree protection zone went out into this road, we knew there weren't any roots out there. So we knew we didn't have to count that. Where the building was a parking lot. So we had a fairly narrow area that these trees were naturally growing in. So we had a good confidence level that we could cut back on that tree protection zone for these trees. And that proved to be a very good assumption. The sixth is other project requirements. They're all competing for space within the tree. Within the design, and you're going to be asking for certain amounts of space, and getting that space can either be very expensive in the case of this tree where they literally just lifted it up and built the building underneath it, or the other tree where originally we had a much bigger area around that tree, and at the very last minute the cut line went within about 5 feet of the base of this tulip poplar. And by the time that happened, we were already committed to saving the tree. The next is construction sequencing. Do the schedules and logistics allow for the things you're asking for? So if the project says, don't grade or mess with the soil in the tree protection area when it's wet and it's raining all the time, there's not much you're going to be able to do about that. Rarely are you going to be able to stop the whole project because we're having a wet spring. The eighth is the flexibility to change your goals. So this tree, where originally we had a very generous tree preservation area, we lost that. And it took us a year, but we finally convinced the owner to take the tree down before the building was completely finished, because we knew it was going to either fall down on the building or it was going to be a really expensive takedown. And sometimes those arguments can be very difficult unless you've got a good relationship with the team. Then there's the end of the project. The last couple of weeks before the project goes in, usually the tree protection fences come down. Those areas which are generally open because there's not a lot of other things suddenly become free range for equipment, storage, all kinds of things that will happen in there. And don't forget that the planting plan within the tree protection zone, if you're adding new plants, can be just as damaging as all these other actions, digging all those holes in your tree protection zone and planting new plants. And often those plants don't do very well because the roots are there. And if you haven't killed the tree often will kill the plants. And finally, the last one is there post-project support. That's probably the most difficult one to get because you leave, you're off the site and there's still, on a large tree, it might be 10, 15 years of very careful protection and watering and other things that have to happen. And if those aren't there, you can be very successful at the end of construction and then lose the tree 5, 10, 15, even 20 years out. So it's a lot more than the tree protection zone. You've got these 10 items that you've got to get. You've got lots of good resources that you can use to help build what you need on your drawings, your specifications, and working with the team. So one more pitch for the tree fund. At some point, we really need you to make a donation if you can to help support our work. Now, I'm going to come back to this slide at the end, but we'll remind you of what you need to do to get your CEUs when we get into the question and answer period. And I think that's my last slide. We're ready to move over to Andrew. So I'm going to stop sharing. And Andrew, you're on.
Andrew, you still muted?
Yeah, no, I'm not. I need to be given host privileges to share screens. I'm listed as a participant apparently, so.
Done.
Okay. Thank you so much. Are we up?
It's thinking about it. Give it a sec.
There we go.
And from the beginning. Okay, can you see it?
Looks good, Andrew.
Okay, so this right here is the Baranoff oak, which is a beautiful oak tree in Safety Harbor in the Tampa Bay area. And you can see that it has a rock solid tree protection stone around it, not from construction, but just from love, because people love this tree and they would trample it to death by walking on its roots, right? Where do roots grow in a tree? I love this picture. This is from the Landscape Below Ground series. This is an artwork that Gary Watson commissioned for his long running and long, just successful series of workshops on the part of the tree that we don't always see, which is the root system. And you can see here that the roots go usually out a lot wider and a lot shallower than most people imagine in their minds, right? And you've probably all heard this, that a decurrent tree that is a spreading tree can have roots that spread 2 to 3 times wider than the crown of the tree. So if you're cutting anywhere in the proximity of that tree, you're probably cutting some roots. How many roots are too many are the questions we tried to answer with this tree fund funded research. And like any rule of thumb, there are definitely trees that are just going to point their put their thumb to the nose to it. This is a bald cypress in Tampa. It's in a really kind of swampy area, really affluent area of the city called Hyde Park. And the urban foresters are struggling to put trees there. They put some bald cypress in, and you can see the knees of this tree go well down. This is some Google Earth imagery that I found of the tree that I took a picture of. And they go all the way down half the block, So that 2 to 3 times, rule, it has exceptions to it. So don't always take things that you see like that as kind of golden rule that biology will not kind of go against. So how are trees damaged in construction? We modeled 2 different versions of this. There's a lot of ways that trees can be damaged. They can be hit by equipment, they can be cut by folks with circular saws trying to make room for equipment and stuff like that. Or often when we talk about root damage, we're talking about changes to the soil around the tree. Here's a tree that was part of a development in my hometown in Florida, where they wanted to make some drainage for this this whole development. And to do that, they dug out around this tree, but they wanted to keep the tree as well. But they dug in below the drip line of this tree, and given its age, given the species, given everything else that was going on in that tree's life, it was too much, and you can see the effects of it as flagging and thinning of the canopy. Trees can die, and all sorts of things. So grading, either adding soil or removing soil, can either smother or remove roots and damage the tree. Here's another image. This is from Illinois when I was working at ISA headquarters as an intern. They were redoing some sidewalks, and this is a common way that trees are damaged. We'll talk about that in a little bit at the end. But you know, a tree that is long-lived could go through one or more sidewalk replacements, often because of its existence near that sidewalk and the lifting that it can cause, right? So when these things are, when sidewalks are replaced or when trenching is occurring next to a tree for utilities or irrigation lines, we can have another form of damage next to a tree where it's just like a straight line cutting of part of the root system of the tree. So this is the second thing that we tried to mirror with our research. First one was kind of like an all-around grade change, where roots are being cut all around the tree. And the second one was a more linear cutting that occurs because of sidewalks or irrigation or any kind of trenching that occurs next to a tree. You know, to avoid these issues, we try to keep them away from the tree as much as possible. And rather than go on good faith and just say, hey, folks, please just, you know, stay away from this tree in this area, and hope that people will be around that you're talking to, and know that we set up tree protection zones, which are fenced off areas that keep the you know, area beneath the tree relatively free of any kind of consequence or damage from construction activities. We want to use heavy duty fencing if possible. A lot of times you see that orange snow fencing, if those of you know what snow fencing are, and that can just easily be moved aside and put back without anyone knowing the difference, or just rolled over, plain outright. And we want to have these things inspected, because if you're only there once or twice during a construction process, you may miss some things that occurred, and then there's regrowth of the grass and things you wouldn't even know that any damage occurred below the tree. So there are different tree protection zone standards throughout the United States and beyond. My student, Andrew Benson, who originally put this together, he is a Welshman from, you know, British, the UK, and he went to school in New Zealand and lived there for the last couple of decades. So he kind of had an English-speaking perspective when he assembled these standards, but they kind of give you a nice range. So like, you know, the British standards and the Australian standards are 12 times the DBH. So if you have 1 centimeter, if you have 1 inch of DBH, you want to go 12 times that, which makes sense if you're doing an English system where 12 inches are in a foot. The New Zealand standards, apparently they don't like using D-tapes, so they just did 4 times the circumference, which is actually the exact same thing, given some rounding from pi, right? And then the ISA BMP, which is the one that many of the North Americans are probably most familiar with, that has a range. It goes from 6 times DBH to 18 times DBH, kind of encapsulating that 12 times DBH kind of standard, but then giving some wiggle room on either side. You'd go less, you get a little closer if the tree's more resilient or younger, but you might want to go a little bit further out if the tree is older or less resilient as a species. But they leave it up to the arborist to kind of get at that. When you look at these standards and you look at the BMPs behind them, you know, the tree fund is so important, because there's usually not a whole lot of research behind our current standards. You know, we do the best we can with the research that's out there, but a lot of it still relies on industry knowledge and, you know, anecdote and our best judgments as professionals, which is good. You know, it gets us a lot of the way there, but having some independent research to kind of just look at things and see if we truly are on the right track is very helpful. Some of the few papers I could think of that I went into this standard would be some work by Gary Watson, where he looked at root pruning around trees, and if you could reduce the influence of that by actually doing some compensatory pruning in the canopy, balancing out the water loss ratio there by what the tree can pick up with its roots and what it loses with its leaves. There's some work by Miller and Neely on the University of Illinois campus, where they actually just looked at a bunch of trees that had been trenched next to by some construction crews and used it as an observational study set to see, based on distance from the tree where the trenching occurred, how much damage was inflicted on the trees. And it was quite a big population in that. And then more recently, Smiley did some work where he was pruning young willow oak, and he was pulling them over to see at what point does getting too close to the tree with trenching affect its stability, but not really looking at the health of the tree whatsoever. So this study right here kind of builds on some of the methods in the past and kind of simulates some trenching activities, looks purely at the physiological side of the equation. Where Smiley looked at whether or not trees are more susceptible to tipping, we're looking purely in these two studies I'm going to show here, whether or not the tree is going to have any physiological stress associated with trenching nearer or farther from it. So this is some studies. This is pretty funny. Like it's hard to find trees that are available, that we know their history, that we can kind of terrorize with this research and do a controlled study of them. These trees are expensive, they're rare, compared to maybe a pea plant in a little 4-inch container. So this study actually took place on the grounds of my research center. We had about 100 or so trees that were planted 15 years ago when the center was built. And my boss was just kind enough to let us cut down trees and hopefully not kill them was our guarantee. So I was pretty happy that he had the foresight to let us do that. And our data set is because of him and his generosity. So here's the site, a bunch of trees planted around the grounds. We had about 100 of them all together. We used a smaller subsample for this study. All live oak, which is a very common tree species throughout the south of the United States, southeast, and it's a very populous area, and it's a very common tree. It's one of the most commonly planted shade trees. So it's a good study organism for a wide range of application. That said, it's also a very resilient species. So we had 30-foot trenches that we blasted next to the tree at 3 times the DBH from the tree, 6 times the DBH from the tree, and then 12 times the DBH from the tree, going up into the standard. And then we left some trees uncontrolled and just monitored their health as a comparison to our control. And what we did is we air spaded these and then made clean cuts with a handsaw. It's more than, it's kind of an abstraction of what you get with a trencher, but we wanted to cut where we wanted to cut it and make sure that was precise and not do any undue, tearing or ripping. And we also cut sections out to make sure that we didn't have connections when we were done afterwards. Here's an example of a few of the treatments going from really close to further out. Air spading in Florida is really fun, especially as my students found out if you hit a fire ant nest, it just comes raining fire back at you. Just a bunch of angry ants wondering why you disrupted their whatever they do, their hate pile. So we did hand cutting these trenches, removed the sections, and what Andrew did when he was measuring this is he wanted to get a section from each root that we cut to figure out what the total cross-sectional root area was that was being influenced by these trenching treatments. So you hear the cuts, he's measuring them all. And then he did something really cool, is he used an electronic impedance sonic tomography system, just the electronic one, to calculate the sapwood area of the tree. He read a paper and he recreated the entire methods in an R code, kind of script, and he was able to figure out how much sapwood area was on the trees, and then that's related to, the root area that we cut, right? So, through pipe theory, we know that the sapwood is going to be in proportion to the rooting area. And it was a good way to get at how much root out of the whole root system was cut without having to dig up everything and measure what was still there. Here's that paper. Just looking at moisture differences and the electrical flow through that, you could figure out what was heartwood or non-functioning sapwood and what was active sapwood in these trees. Pretty cool. He did it like in a week. It was pretty amazing. He also looked at diameter growth, twig growth. We had like the world's lamest pogo stick, which is this water potential meter. It's a pump up water pressure. What you do is you put a leaf in this thing and you pump it up. And if a tree is water stressed, it takes a lot of pressure to get that water out of the leaf end. And if a tree is not stressed, it'll give up water a lot quicker with less pressure. And we can tell relatively through this means whether a tree is water stressed compared to the companions on the site if it's the same species, right? And then we have another thing. It's we looked at chlorophyll fluorescence, which is essentially a really fancy flashlight that you shine on a leaf. And if a leaf is stressed, it won't absorb that light, and a lot of that light will bounce back because it's not photosynthesizing to its max potential. And we can use that information to look at stress before the trees start giving us any symptoms, visibly. So looking at our treatments, we saw some things we want to see in that the controls were the healthiest. This is twig growth right here. And that, we did see a measurable decrease in twig growth for the other treatments. The 6X had the least twig growth. The 3X actually had a little bit more twig growth than the 6 times diameter. And then the further out we got, the less damage we saw. So, things you'd expect in your results. When we look at trunk diameter, even though there's still the same pattern, the variance in the data was so much that we couldn't discern any statistical differences. So we did not pick up trunk diameter growth from having a portion of the root system disrupted through trenching. And then this is a pretty busy figure, but he's looking at water stress here, and he's looking at how the different treatments differ. And if you just look at the asterisks at the bottom, you can see that there's noticeable increases in water stress for pretty much every treatment at the start. But by day 440, which is a year later when he came back after an ISA conference back to Florida where these trees were, everything had gone back to normal, right? All the 6X and the 12X treatments had kind of recovered from the damage, and they were no longer more water stressed the controls. But the ones that had trenching that were 3 times diameter, so really close, they actually still had water stress 1 year later after the storm, after the treatments, sorry. So I mentioned the storm by accident, but there was a storm that happened. So we had Hurricane Irma hit these trees shortly after the treatments were, given to the trees, and none of the trees toppled. So that was an unexpected finding, and I was happy that none of them toppled because I told my boss nothing was going to happen to them. So that was a great, just kind of just one of those scientific things that just happens, right? So water stress was observed at, for all treatments up front in the first growing season, but it went away, that water stress went away for all but the most closely trenched trees, which were the 3X treatments, the 3 times diameter treatments. So if you want to avoid water stress, long-term water stress in trenching around trees, keep to 6 times diameter or more, given our research, taking all the caveats that Jim said before, into account the species and the size and all that stuff. Here's the paper that Benson wrote, and I was a co-author on. And if you guys go on ResearchGate and send me a link, a request, I can send this to you, no problem. I'll do it that day when I get the notice. If you don't know that, ResearchGate is like, Facebook for nerds, and we have a lot of our papers on there that we can just give to you, so you don't have to pay for these things ever, okay? Second study was, going all the way around the tree. Say you're going to, lower the grade, raise the grade, Maybe you just really hate trees, you want to trench all the way around them, I don't know. But we're trying to mimic that damage for this study. This was at a different University of Florida research station. These were some trees that Ed Gilman had used for a previous project, and they had been allowed to grow, and we revisited them. These are actually closer to Gainesville in North Florida. And so here are, again, we're using our same species live oak, Orchis virginiana. And here are our treatments. This time we had circular trenches, and we had, you know, some of the same things that we saw in the last study, but we went a little further. So we had a circular trench going all the way around the tree that was 3 times the diameter, 6 times the diameter, 9 times the diameter, 12 times the diameter, 15 times, and then a control that was not influenced by trenching at all. Here are what our trenches look like. You can see they get pretty close, right? And that's a pretty, you know, that's not a lot of root system left intact in the one lower right picture, right? And then going further out at the top, you have some wider trunk protection zones that are actually going beyond the drip line. If you look at our radiuses of our tree protection zones here and their impact on water stress, you can see that the control had the least. So water stress is a negative measurement, and the more negative you go, the more water stressed it is, right? So our control is the least negative, so it's the least water stressed. But then you can see there's a pattern where all of the treatments did increase water stress, but given the variability in our data and our replications, which were 3 times because trees are expensive at this size, we did not detect a difference in the 15x compared to control, but you can see it there. And again, you know, water stress just increasing the closer you get to the tree. Twig growth, we did not really detect a statistically significant difference in twig growth for the 15x and the 12x treatment. Notable decreases in twig growth were statistically notable ones were seen for the more close treatments. And then trunk growth, again, low reps kind of hindered our ability to detect differences here, but the 2 closest ones were the most detrimental to long-term trunk growth. So key findings from this is that the existing 12x DBH guidelines for tree protection zones were sufficient to prevent long-term growth impacts for medium-sized live oak, right? And in all of the studies and all of our treatments for both of these, not a single tree died, right? So, I mean, that tells you something right there. And even short-term water stress, if you wanted to prevent any kind of water stress from occurring, and this is probably the case when you're dealing with an older tree or a tree that's already showing a little bit of stress, but you want to keep it anyways because it's significant, going to the 15 times DBH was important, and we didn't detect any differences in water stress when we got to that level. So going beyond the 12x, that's normal for some of the standards, but still within the BMP range. And again, not a single tree toppled during Hurricane Irma, even the ones that were pruned really close at 3x. And here's that paper. Again, if you want this, contact me after the show on ResearchGate, and I will send it to you as soon as I can. And finally, I hope I'm not going too long, but this is a study that I'm really proud of. It's something that one of my other PhD students, Deb Hilbert, was working on, and I think it's going to be very useful for folks. So what we're doing is we're looking at minimum planting with requirements for sidewalk conflicts. So when you have a tree growing in a built environment, you have 2 things. You have minimum root volumes, which Jim actually has a really good figure in his Up by Roots book. If you don't have that book, you should have it. And it's just, you know, how much soil volume is there to accommodate a tree as it grows and needs to suck up water during the hottest parts of the year. We're going to contrast that with what we're focusing on for this study, which is minimum planting width, which is how much space does a tree need when rooting volume is not limiting, where the roots can go underneath sidewalks, can go down tree terraces, alongside a street, where it's not an issue of volume, but it's an issue of conflicts with nearby infrastructure. Because you see things like this all the time. You know, that big live oak I showed you in the pictures before. This is what you get from the nursery, right? It looks like it fits perfectly in this planting spot, which is, you know, in highly compacted developments where they're most profitable right now for developers. And so people plant these trees not knowing that they're going to set themselves up for failure. You know, talking with the city of Tampa, they spend $1.5 million annually on sidewalk repair. And our research shows that a good portion of that is probably tree related, you know, and it probably comes to no surprise to anyone who works in urban forestry role. And then here's another picture. This is from the Tampa Tribune, which used to be a paper here in the area. And there was a development here called Seven Oaks, who now truly has 7 oaks in it. I mean, they had 2,000 trees removed at once because they all started interfering with the sidewalks at the same time. And it was just a losing battle. They knew that these trees had no future. And sidewalks, you know, if you've ever seen someone in a wheelchair try to hop over an uneven sidewalk, you know why we have ADA standards, right? So how do we prevent this from happening? How do we prevent us from cutting down trees before they've given us any of the benefits that we promised that they're going to give us, you know? And one is to give them enough space. You know, there's a zone of rapid taper next to the trees where their large buttress roots are going to be the things that can really lift up sidewalks, right? And past research has shown that this can go about 4 feet or 1.2 meters beyond the visible roots of a tree. And we know how big trees can get with regard to their diameter because we have a lot of inventory data. That's one of the most common things that we record is diameter data as DBH, right? So what we try to do with the study is make allometric equations predict trunk flare based on DBH, so we could make an equation that people could plug into their spreadsheets and figure out minimum planting widths for the most common trees in their area. We did this in Tampa, Minneapolis, St. Paul, Milwaukee, with 2 common oak species down by us, laurel oak and live oak, and a bunch of other species up in like your ashes and your maples up in the Northeast, in the Great Lakes area. And what we did is we just measured DBH, we measured trunk flare in these species to create the equations. And we looked at how, you know, differences in their rooting environment, given, you know, nearby infrastructure and ground cover and exposure and irrigation, all sorts of things, if that influenced at all, and none of those things mattered. It was a very solid and very tight relationship. We also looked at, you know, what damage we saw, and we found that in our case, we had about 1/3 of our trees that we measured just randomly out of a sampling of inventory trees in the Tampa area were indeed causing infrastructure damage. So it's a very prevalent problem in urban areas, and we found that just haphazardly in our study. You know, out of 104 live oak and 101 laurel oak, you know, we found that 37% of them and 38% of them were causing damage to nearby infrastructure. And there was quite a bit of stem girdling roots there too, which was just kind of another side that we found. I said these relationships are pretty tight, which allows us to predict the rooting flare, the root flare distance based on DBH to a relatively high level of precision, which is comforting. And what we did is we put this paper and we actually made equations for you to use in your own work. Take your own tree data and figure out how much space you need based on whether the tree is from an upland, because they were so consistent. We were able to group them into upland trees, wetland trees, and then the more plastic trees like your red maples that can go in different environments. And we have equations for each one of those species for you to use. So when we do this, you know, to figure out the space we need, we figure out the projected trunk flare distance, which is diameter, which is what we generate from that last equation. We scale it into feet, and we add, you know, 4-foot buffer on each side or 1.2 meter buffer on each side. And we figure out that for live oaks and laurel oaks, believe it or not, you'll need, if you want it to grow to its maximum urban potential that we found in our data, you need 15 feet I mean, and that's a big ask. We know that, right? But I just wanted to show you that number to show you what we're getting into when we plant large shade trees in urban environments, right? And if you don't want to give them that much space, then you can use these equations to figure out when they're going to cause problems, right? Because, you know, not every tree is going to live to be a grand tree in an urban area. No, we know that. But we can use these equations to kind of figure out what lifespan that tree has before it's going to start causing problems, and then figure out if that's the right species for that site, right? We can actually use this to see, you know, how much stump grinding we need when we plant the tree in the wrong spot, right? Because we can predict how much the trunk will be there to the grind out later on. So they're quite useful, and I hope that you find them useful. And we have an extension sheet coming out for this that'll be translated to Arborist News, so that you can access this in your work. So I just want to give you a little heads up for that. And finally, I went through this pretty quick to keep up the time, but here are the stars for the research. First off is the Tree Fund. They funded a bunch of this research. Also, the Florida Nursery Growers and Landscape Association funded part of it. And then Andrew Benson, seen here, tree spading below the trees at the Center for the Trenting Trials, and Deb Hilbert hugging a tree on her way to some QTRA training in the UK. So with that, I will let Bo take over, or I think it's Jim actually. So.
Thank you, Andrew, and thanks, Jim. And Jim, have you been monitoring the Q&A box? Because we have, I think, a lot of questions, and you guys did a fantastic job with, I think, helping us begin to answer some of those questions that are the most challenging, which is, you know, how many roots can you actually cut and expect a tree to survive? And Andrew, I'll throw out one question that came up repeatedly, and that is, there was people asking, with your two studies, how deep did you trench around those trees, and how long did you observe the trees for? I think there was a number of questions that came up.
Yeah, we observed them for 2 years. So that's the first part, and then I did ask Benson about that again with the trenching. We at least went 18 inches, but I think he's pretty much went until they ran out of roots. You know, so they're mostly surface roots. He just made sure that they were all cut on that one side. You know, so yeah, that helps.
No, absolutely. There's also a number of questions, people wanting the citations to your publications. Do you think you could send some links to Monica, and maybe we can post those along with the recorded presentation on the Tree Fund site? Is that something? I'm not sure if those are open source journals or not.
I'll give you the links to my ResearchGate page, and then I can use it as a gatekeeper to keep sending it to people. You know, they don't like it being given away for free, but if you request it, it's a different beast. So definitely.
Okay, perfect. Jim, you're muted. Hold on. You need to unmute yourself. I see you're talking.
There we go. So we're almost at the top of the hour, so we should just, we can go longer for anyone who can wait, but we should clean up the CEU issues. I got several requests saying what is the situation for ISA CEUs, and Bo, can you repeat what you said about ISA CEUs?
Absolutely. The ISA CEUs will be based on the name and certification number you put in during the registration process for this webinar, and then also compared to today's attendance records. And so if you attended today and provided us the information during registration, we will send that directly to ISA on your behalf. So we will not be posting a code. You will not be submitting it yourselves. We will do it for you. Allow ISA 4 to 6 weeks is what they ask for time for them to post it. So it takes them some time for it to show up in your account.
Also for the ASLA CEUs, Monica has posted a thing you can click on for taking the test. It's quickly getting buried up in time, but she posted it around 4:58, so you can, in the chat box, so you can scroll up to that time. I see she's posted it again, but it's getting buried, but you can find it on the chat box. And if you somehow just can't find it, there's an email here on this screen, the Tree Fund webinars@gmail.com. You can email that and you will get the link sent to you. Let's see, and for what it's worth, one more time, if you felt this was a valuable service to you, a donation to the Tree Fund would be greatly appreciated. And we have the evaluation poll in progress, and we are open for questions. And Bo, I don't know if you noticed, I answered questions up to about 4:30. Let's see. I did have one question where somebody wanted to know if I would share my slides, and the answer is yes, but you need to send me an email. So if you send an email to Jim Tree, the numbers 123 @gmail.com, Jim Tree 123 @gmail.com, and ask for the slides. I will send you my PowerPoint presentation. Bo, you want to continue on with questions? We can go.
Sure. And there's a ton of them here, and I'm going to try to find one. There's one that was of interest. Yeah, it says, how can you estimate how deep the tree roots extend on an existing tree? For example, if a retaining wall ties back are proposed to run 20 feet underneath an existing tree, how can you tell if this is within the CRZ?
Right, and I would, just guessing, I would say that if the tiebacks are 20 feet down, they're probably well below the root system. I use a Dutch auger in my work to find the extent of roots that I can find, and I might take and dig 5 or 6 or more holes. These are 3 inches in diameter and 3 feet to 4 feet deep. And usually by the time I get down to 4 feet, I'm clearly out of any, finding any roots. Other soil conditions might be different, so you really need to know, understand your soil. But even if there were roots at 20 feet and you were putting your tiebacks, I doubt you'd do enough damage at that point to make any significant difference to the tree.
Yeah, agreed.
And let's see here. There was a question here about boring under trees and boring under the TPZ, and what depth and what are the recommendations there. And I know there's some information on that in the ISA BMP, but Andrew, Jim, do you have any suggestions for people? It's not well researched that I'm aware of.
No, I know when I worked at ISA, they had a trenching and tunneling video set that they worked on with the utility sector. That might have some guidelines. I'm not sure if it's still available, but that would be a good source because they worked on do like some best practices for that.
But again, I would say that first I would try to understand the soil, and obviously the larger some of these large trees, I've seen really heavy buttress roots at 4 and 5 feet deep, but usually the top 3 feet. Within the first 8 to 10 feet radius around the tree, you get the deepest, heaviest roots. But once you get beyond that point, things are pretty much in the top 1 to 2 feet. But you're going to be able to find that with your Dutch auger. I think that every landscape architect and arborist should own a Dutch auger. They're a couple $100, price of taking a couple of people out for lunch. You can't go out for lunch these days, so buy a Dutch auger. You'll love it.
And I'll just say, I know some of you need to run. feel free to go. We'll stay on for another couple minutes and answer a few more questions, but for those of you needing to get on, that's fine. Andrew, here was a question. It says, in addition to species selection for DBH and TFD, I'm not exactly sure what that stands for.
The trunk flare diameter.
Okay. Yeah. Can you share thoughts about the use of permeable sidewalk surfaces and design concepts for urban development planning of undulating walkways that would include large planting spaces as well as narrow ones?
So, I mean, the trunk flare diameter thing that we showed at the very end, that's going to prevent any sort of conflicts of any kind of paving surface. So that's just kind of a clear zone to prevent, you know, even like a wavy or like a regular surface that can, you know, grow over the root system. But having the porous pavers around there, that'll just give the roots, the finer roots, the ropier roots, more access to air and moisture, which is what they need to grow, you know? So I think that's fine, you know? Again, keeping the immediate area next to the tree clear to prevent any sort of uplifting.
And here's a question, you know, because your trenching studies both were done, I think, on Quercus virginiana, and somebody asked, you know, how do other species handle, you know, trenching? Do some handle it better than others?
Yeah, I'm sure. I mean, Quercus virginiana, while a very common tree, is also a very resilient tree. You know, drought resistant, just it's a tenacious urban species, right? So I think other species would have a harder time, you know, in that regard. And that there's, you know, a guide that Matheny and Clark put out there where they looked at. Jim, do you remember the name of the book, the Blue Book?
Yeah, well, it's easiest to use the ISA BMP, and they have the entire Clark-Matheny list of tree tolerance.
Yeah.
In there. So, you know, use that as a guide for anything you're doing around tree. And if it's intolerant of construction, you need to be much more aware than a tree that is tolerant of construction.
Exactly, yeah.
Okay. So with that, I know we are now 7 minutes past the hour, so I think we should probably bring this to a conclusion. And I did see a question about CEUs and what if more than one person was watching from your console. That's a tough one, and we actually asked for guidance from ISA on that one. And if your supervisor can send a note, that's fine, and just send us your names and certification numbers saying that, you know, you watched the webinar with you. And, you know, it comes down to ethics, and so that's the word we got from ISA. So
yes,
if you're,
please send it to treefundwebinars@gmail.com, and we will process that for you.
Yeah, and I would say the same for the landscape architects, LACES CEUs. If you have multiple people watching, send an email to the Tree Fund Webinars at gmail.com stating, you know, who was the person registered on the call, and then who was also in attendance on the call.
well, with that, Dr. Koeser and Mr. Urban, thank you very much for fantastic presentations today. I think these talks really, I mean, looking at the number of questions we have, and I apologize we didn't get to those, really gets to some of the major challenges we have in urban forest management. And I think the piece of research, Dr. Koeser, that you and your graduate students, Dim, and Jim, your experience with working on this for a number of years, I think is invaluable. As a reminder, this webinar was recorded. It will be on the Tree Fund website, and you will be able to take a look at those citations that Andrew Koeser mentioned. And I know those will get to a lot of your methodological questions that many of you had. So with that, thank you very much. Monica, do we have any closing comments on the Tree Fund fundraising side? I've seen it was very active. Thank you to everybody.
It was. We raised over $3,000 during this webinar, during this 1 hour. So thank you all very much.
Wow, fantastic. Thank you all. That's good news to fund the type of research that we saw here today. So thank you. And with that, Jim, any closing comments before I shut the webinar down?
Nope, thank you all, and keep learning more about trees.
Thank you, Andrew.
Yep, no problem. It was a pleasure.
Yeah. And I will talk to you guys at the next webinar. Oh, as a reminder, yes, the next webinar comes up when, Monica?
July 14th at 4 p.m. Central Time.
So another late afternoon one, at least for us in Central Time. So thank you all and join us then. Have a good afternoon. Thank you.
Thank you.